Hello and good day, or if we're in ATC, howdy and good day. Coming to you from La Casa del Schultz, taking a break from my Mario Maker playing to go over CO11. I can solve absolute value equations with you. Okay, so one term to define here. If we're solving absolute value equations, we should know what the definition of absolute value is. Okay, and does everyone know the definition of absolute value? Good, all of you, excellent. Well, the definition of absolute value is the distance of a number from zero. Okay, the distance of a number from zero. Is my penmanship just excellent? The distance of a number from zero. And the key word here in this definition is the word distance. Okay, because I think we've talked about this before. When it comes to a distance, what do you never see on a ruler? A negative side, right? You can't measure something and have it be a negative distance. If you are in a car and you drive the car in reverse, does the odometer start to count down the miles? No, it still counts up. Okay, you are still going a distance even though it's backwards. Okay, so the by mere nature, an absolute value. Okay, what's inside what we're called absolute value bars? If you look down the page, they look kind of like this. Okay, what's inside absolute value bars cannot be negative because it is a distance of that value from zero. How far is the number 9 from 0? 9. Therefore, the absolute value of 9 equals 9. Okay, how far is it? How far is negative 9 from 0? Well, negative 9 is still a distance of, not 0. Negative 9 is still a distance of 9. Okay, so general rule of thumb, whatever is inside absolute value bars will always come out positive because by definition, being a distance, it has to. Okay, so when we solve absolute value equations, our goal is to use opposite operations to isolate the absolute value bars. Okay, and then once we do that, we create two equations to solve. I'll highlight that in red here. So the goal here, and I'll back this up so that it all fits on one line. Okay. Oop, yes, I can do that. Okay. So the goal is to use opposite operations to isolate the absolute value bars. And once we do that, we are going to create two equations to solve. Use opposite operations to isolate the absolute value bars and then create two equations to solve. Why two equations to solve? Well, because we need two answers here. Okay. And the reason why we need two answers is because there are two sides to 0. And you'll see more what I mean by that when we actually start to practice this. The biggest mistake that folks make when dealing with absolute value bars, I'm going to highlight this here so it's extra special. How do I? There it is. Okay. You cannot distribute a coefficient into absolute value bars like we just got done doing with parentheses, right? The distributor property, you distribute a coefficient into parentheses. You can't do that with absolute value bars. They are strong like a fortress. Okay. Unlike parentheses, which are weak stocks swaying in the wind. Okay, weak. All right. So just remember that. So down here further, we get to some practice examples here. Show your work, and then you've checked your answers just like with equations before. So this first one, we're going to start here. The absolute value of n equals 7. And because that variable n is inside those absolute value bars, when we see that, what this is saying to us verbally, how we can interpret this is n is a distance of 7 from 0. Remember, those absolute value bars mean how far it is from 0. So if the absolute value of n equals 7, that means the distance of n is 7 from 0. So what two numbers are a distance of 7 from 0? Well, 7 is a distance of 7 from 0, and so is, oh boy, gotta go through this. So is -7. So before, when I said that we are looking for two answers here because there are two sides to 0, if I ask you, give me a number that is a distance of 7 from 0, there are two numbers that satisfy that. Both 7 and -7 are a distance of 7 from 0. And so to check this, we can type in here, the absolute value of 7, just replacing n with 7, equals 7. Is that true? Yes, it is. Check. The absolute value of, I'm not going to do that thing again. I'll just use that sign, of -7 equals 7. Is -7 a distance of 7 from 0? Yes. So that also works. Okay. So just to recap that one more time, what we're doing here is when we see those absolute value bars, we are thinking of that as a distance. Some number, right? Some number, a variable, some number is a distance of 7 from 0. So what two numbers could that be? 7 and -7. In the second one here, the absolute value of n plus 1 equals 66. The absolute value of n plus 1 equals 66. When we see that n plus 1 inside of those absolute value bars, we're thinking to ourselves, n plus 1 is a distance of 66 from 0, right? N plus 1 is a distance of 66 from 0, which means that term, that expression rather, n plus 1 can be either 66 or it can be -66, because both -66 and +66 are a distance of 66 from 0. So earlier when I said that we're looking for two equations here, the two equations that we can create is we want to figure out what can n be so that it equals 66, n plus 1, and what can n be so that n plus 1 equals -66. Because both 66 and -66 are a distance of 66 from 0. So what could n be so that makes n plus 1 66 away from 0? Okay. So we'll subtract 1 from both sides here to get n by itself. N equals 65. 65. We subtract 1 from both sides here to get n by itself, and n equals -67. Right? Those are the two values for n that are going to make this equation true. To check, right, we just go back to the original equation and we say, is the distance of 65, replacing n with 65 now, 65 plus 1, is that 66 away from 0? Well, because 65 plus 1 equals 66, yes, it's a distance of 66 away from 0. Our other value for n was -67. So we plug that in, -67 in for n, and we say, is -67 plus 1 a distance of 66 away from 0? Well, even though -67 plus 1 equals -66, how far is that away from 0? 66 numbers away from 0. So yes, n can be both 65 and -67, because when you add 1 to both of those values, your result is 66 away from 0. Whew! Mind's blown, perhaps? Okay. This is big brain math here. Okay. Thinking about this in terms of how far away from 0. So the next one here. The absolute value of 3n plus 2 equals 13. So now we've got more stuff inside of our parentheses here. The absolute value of 3n plus 2 equals 13. What we're thinking here is 3n plus 2 is a distance of 13 from 0. So what can 3n plus 2 equal? That's a distance of 13 from 0. Both 13 and Can't find my mouse. All right. 13 and negative 13 are a distance of 13 from 0. And these numbers are important because these are the numbers that we are going to set our two equations equal to. We want to know what value for n makes 3n plus 2 equal to positive 13, which is 13 away from 0, and what value for n makes 3n plus 2 equal to negative 13, which is also 13 away from 0. Notice that my 3n plus 2 doesn't change, right? My 3n plus 2 is the same in both equations that I'm writing here. What changes is the sign of my solution, 13, negative 13. And I can do that because by definition, both of those values are 13 away from 0. So we have a two-step equation here. We're going to start by subtracting 2 from both sides. We get 3n equals 11. Divide both sides by 3, and we get n equals 11 thirds. And we freak out for only a second because it's a fraction. It doesn't work out evenly, but then we remember that we're in algebra. Fractions aren't that scary. We're okay. Everything will be fine, and that's okay. All right. This next one here, same thing. Subtract 2 from both sides. We get 3n equals negative 15. We breathe a little bit sigh of relief because we see that in this case, dividing by 3, we get negative 5, and that works out evenly. I have a feeling I'm going to run out of space here pretty soon, so I'm going to, let's see, we're going to shrink that down and shrink this down. Don't you love these mid-lesson production meetings? Mid-lesson edits. Ooh, just to make my life easier. Okay, there we go. So our two solutions for n are 11 thirds and negative 5. Those are the two values for n that will make 3n plus 2 a distance of 13 from 0. So when we go to check, we say the absolute value of 3 times 11 thirds times 11 thirds. Okay, close my parentheses. Plus 2. Does that in fact equal 13? Well, 3 times 11 thirds, based on what we know about multiplying fractions, that 3 is like a 3 over 1, right? So 3 times 11 is 33 over 3, 33 thirds. That just ends up equaling 11. Those 3's essentially end up canceling out. So 11 plus 2 equals 13, which is 13 away from 0. That checks out. On this side, for this answer, we have 3 times negative 5 plus 2. Well, 3 times negative 5 is negative 15. Negative 15 plus 2 equals negative 13. And negative 13 is a distance of 13 from 0. So both values work. All right. So again, our process here. Once we get the absolute value bars by themselves, which in all 3 examples that we've done so far, they already have been, okay, we look and see what's inside, and we think of that expression as a distance from 0. We set that expression. In this last example, it was 3n plus 2. We set that expression equal to both the positive and negative value of our solution, because both of those numbers, 13 and negative 13, are a distance of 13 from 0. Okay, we solve each equation, we get our solutions, plug them back in, we check, and we make sure it works. This fourth example here, the bars are not by themselves, right? We have the absolute value of n minus 7, we close that, and then we're adding 5. So our first step here is following our goal from up above, using opposite operations, we are going to get the bars by themselves. So I'm going to subtract 5 from both sides, and that leaves me with n minus 7 equals negative 3, right? Because 2 minus 5 equals negative 3. Now, if we change this to the verbal like we did in the first 3 examples, and think about this as, okay, So n minus 7 is a distance of negative 3 from 0. N minus 7 is a distance of negative 3 from 0. We kind of run into a problem here. Because back in our definition at the top of the page, we said, what can a distance not be? A distance cannot be negative, right? How can the distance of n minus 7, how can that be a distance of negative 3 from 0? It doesn't make any sense. So we first ran into no solution type equations in PO10. This would be another example of a no solution type of the equation. There is no value for n that is going to give us a distance of negative 3 from 0, because a distance cannot be negative. Okay? So far, so good? I'll assume this all makes sense to you. I can't really tell anyway, so we'll move on to the next two examples here. So for these two examples, there is an initial step, which I'll go over with you, okay? And then I want you to do the rest of it yourself, right? So this first one, we have 6 times the absolute value of n minus 9 equals 18. I see that 6 out in front of my absolute value bars, and I know I've got to get those bars by themselves first. I might be tempted to distribute that 6 into the absolute value bars, but then I realize absolute value bars, strong, like fortress, okay? I cannot distribute. So what do? How do I get rid of that 6? Well, if I'm multiplying 6 by the absolute value of n minus 9, the opposite of multiplying n minus 9 by 6 is dividing by 6. So opposite operations come into play here. I'm going to divide both sides by 6, and now I've got the absolute value of n minus 9 equals 3, because 18 divided by 6 equals 3. Now it's very similar to what we have up above, and so you can take that, you can think about this as, okay, n minus 9 is a distance of 3 from 0, which means n minus 9 has to be either this or this. You make your two equations and you solve. So follow your notes from up above to get to the end for this one. Next one, same situation here, right? I've got 2 times the absolute value of 4n plus 11. That 2 is a problem because I have to get the bars by themselves. So I'm going to divide by 2 to get the absolute value of 4n plus 11 equals 24. Right? 48 divided by 2 equals 24. I highly recommend that on your help sheet, you write on there, do not distribute into absolute value bars. Okay? It's a very common mistake that is made, and you just can't do it. Okay? 2 is not part of that distance. Right? But now we have the distance of 4n plus 11 equals 24. So we can break it up in our two equations like we did in the previous examples. Okay, and that brings us to absolute deviation. An absolute deviation is kind of an application of absolute value, but with numbers other than 0. So our definition for absolute deviation is going to be an amount above or below a given, oh my gosh, if I could type, it would be helpful. A given value, an amount above or below a given value. And all of these examples here are real life applications because you've probably run into a situation like this before. So you 8th graders, those of you taking geometry, Apparently, I'm still recording. Sorry about that. I lost internet and I thought that was going to cut me off. So anyway, back to it here. Um, so absolute deviation is an amount above or below a given value. Okay. So for example, you eighth graders are going to be taking, if you're in geometry, a geometry test, a placement test to see if you can test out of it or not. And so what they're looking for, it says, in order to test into geometry in high school, a student needs a placement test score of 80 points with an absolute deviation of 8 points. So this phrase absolute deviation here, absolute deviation, refers to an amount above or below a given value. In this case, that amount above or below a given value is 8. The given value is 80. So we think about this and we say, all right, well, the target score is 80, but you can get either 8 above that, or you can get, this is going to turn into an arrow for me. Oh, it is fantastic. 8 below that. Okay, which means that the scores you can get to get into geometry gives you a bit of a range here, is 72 through 88, right? 8 below 80 and 8 above 80. 8 above 80. So if you get a 72, it probably means that you're going to be kind of on the lower end of the class. You might have to work a little harder. It's going to be a little more of a challenge, but you still belong there. You've shown enough that you tested out of or test into. Oh, I didn't even read my question. Test into geometry. Okay. If you score an 88, it's probably going to come a little bit easier for you. You have a good background of geometry already. You kind of understand what's going on here, and you'll be probably one of the higher kids in the class. If you score 80, you're going to be right about average. Okay, so that's what absolute deviation is all about. It's a value above or below a given value. The next one, on the NWA map tests, your RIT score has an absolute deviation of 3. If your RIT score is 230, what is the range of possible RIT scores you're likely to get if you immediately took the test again? Yeah, funny thing about those RIT scores is that they all have an absolute deviation of 3, meaning that if you took the test immediately again or the next day or whatever, you would get an absolute deviation of 3, a very high percentage chance. You get an absolute deviation of 3 from your original score. So in this case, that amount is 3 and the given value is 230. What's your range of scores you would get? Professional bowling regulations require a bowling pin be 15 inches tall with an absolute deviation of 0.0035 inches. What is the range of heights a bowling pin used in competition? I'm so embarrassed. A bowling pin used in competition could be. So 15 is the target numbers, which you're trying to get there, but human error exists, machine error exists. It could be 0.0035 inches higher, taller, or 0.0035 inches shorter. In figure skating competition, a program must be 3 minutes, 30 seconds long with an absolute deviation of 9 seconds. Those of you in competition, anything where you're putting on a bit of a program, I mean, no one wants to try and judge a performance that lasts, 15 seconds versus a performance that lasts 18 minutes. Okay, they want them all to kind of be more or less the same. So you're trying to get your program to be 3 minutes, 30 seconds, but they do give you an allowance of an absolute deviation of 9 seconds. Okay, so what range of times does your program need to be? For every second outside of that range, a point is deducted. They say, nope, you are too short, we're taking points off. Or, nope, that went too long, we are taking points off. So how many points would be deducted from a program that was 3 minutes and 15 seconds long? Okay, outside of that absolute deviation range. And finally, the average amount of time it takes me to drive to work from daycare is 24 minutes, 18 seconds with an absolute deviation of 53 seconds. If I leave at daycare at 6:55 a.m., give the range of times you should expect to see me running in the school, dragging his kids behind me while apologizing to Mrs. Dawson that he's late. right? So if I leave at 6:55 a.m., it takes me on average 24 minutes 18 seconds. So what time would I arrive? But there's an absolute deviation of 53 seconds. So what's that range of times you can expect me to finally be walking in the door of the school? Okay, so absolute value, absolute deviation, both things kind of going with that an amount or a distance from a given amount. And the more real life application of these two is obviously absolute deviation. That's all for the lesson today. Do complete all of CO11 for homework. It is due tomorrow. Also due tomorrow, well, due tonight actually, Khan Academy, but you literally the entire day to finish it. It is not due until 11:59 p.m. Also, football picks are available in Google Classroom if you are still doing that. Week 7 picks. First game is tonight at 7:15. And I believe that's it. That, folks, is How You Math. Bye. How do I do this? Oh, here we go. Bye.